Well, hey there, kiddos, and welcome to your video for today. We're going to be talking about how to multiply polynomials. This is part 1 of 2. We're going to do this today, and we're going to do it again tomorrow, so you're going to see this a couple of times. This part 1 is going to be just a lot like doing the distributive property. Just we have to remember what our rules with exponents are, which is why we spent so long learning those. So the first thing that we have to do, we're going to learn how to do this using algebra tiles. Now, again, just like on the notes from yesterday, I'm going to be able to move mine around. You're just going to need to draw yours. But it would help if you drew this offset little T-chart, because it's going to help us with multiplication, and it's going to come in really handy later, especially if you're a visual person and you need to be able to see what's happening like this. So I'm going to multiply x times 2x plus 4 using my algebra tiles. And so the first thing I'm going to do is I'm going to put my x over here, and then I'm going to put my 2x plus 4 over here. So I'm going to have 2x and then my 4 over here. So you need to draw this on yours so that you will have it. And as I do this with algebra tiles, I'm also going to do it algebraically so that you can see both things happening. And you have room on your notes to do algebra tiles in one part and algebraically in the other, so that you will see how the algebra tiles match with the actual algebra. So if you'll remember, when I do x times x, what that makes is an x squared. And so when I multiply these two together, this is going to make an x squared right here. But then I also have to do x times this x, because I had 2 of them. So now I have 2x squared. And then I have to do x times each one of these 4 times. So I'm going to have to do x times 1 makes x. And then x times another one makes another x. And I'm rotating them so they line up in a pretty little rectangle, because that's the goal when we do this kind of problem, is to make a pretty little rectangle. And so this is what I end up with when I do x squared times the quantity 2x plus 4. I end up with 2x squared plus 4x's. And so that's what I have here when I finish multiplying. It comes out to 2x squareds plus 4x's. That's what I got. And so I'm going to show you algebraically how I do that. It's just the distributive property. The first thing I have to do is x times 2x. Well, we talked about properties of exponents, and when I am multiplying things that have exponents, and these have little invisible ones here, I add up the exponents. So I have my 2x, and I add my exponents to get the squared. And then when I do x times 4, it just becomes 4x. And so algebraically, all I did was the distributive property. With algebra tiles, this is what it looks like, and that's why it worked that way. When I multiply these two x's together, it gives me an x squared, and then I multiply it again because there were 2 of them. That's what happens. And so if you were asked a question involving algebra tiles, that's what it's asking about, and so that's what those pictures mean. That's all that they are. So let's do a few more examples of multiplying involving exponents. So it's just like distributive property. So we're going to do 5a times 2a first. So we multiply coefficients, so that becomes 10. My base is a squared now, because I have an a times an a. Then I have to do 5a times 3b. Well, 5 times 3 makes 15, because I multiply my coefficients. But a times b, they aren't like bases, so I just put them together. It makes ab. And so that's what that looks like multiplied together. Now the next problem is very similar, it's just written backwards. The thing I'm going to distribute is on the right hand side of the parentheses instead of the left. If that messes with you, rewrite it and turn the problem around. So I can rewrite this as 0.5y times 0.5x plus y. These are the same thing. In this instance, the thing I'm going to distribute is on the right, but then this is how you're used to seeing it, so just turn it around. It's multiplication. Order isn't all that important anyway. Order doesn't matter with multiplication, so just flip-flop them. It's okay. So now we're going to distribute 0.5y times 0.5x. Well, coefficients get multiplied. 0.5 times 0.5 does not equal 1. Please do not say 1. What it equals is 0.25. Okay, so 0.5 times 0.5. If you think about it, 5 times 5 is 25, and then you have 2 decimal points, so you got to move it and have 2 numbers behind the decimal. And then these are not like bases. I have an x and a y, so I'm just going to write x, y, and stick them together like I did my AB over here. If you want to put yx, that's fine. It's just standard notation to put them in alphabetical order. They mean exactly the same thing. Plus, then I have to do 0.5y times y. Well, there is an invisible 1 here. When I do 0.5 times 1, that's just 0.5. And then y times y makes y squared. So there that is, simplified. So the next problem is very much the same, except I'm going to distribute 3 times because there's 3 terms inside that parentheses on the inside. So I'm going to let you pause for just a second and try it, and then come back and check your work. So here's the answer I came up with. I got negative 9x to the third y squared minus 18x squared y squared plus 15x squared y to the third. And none of these are the same, so I can't combine any like terms. And if you're confused about how I came up with that answer, especially if your signs are different than mine, ask me about that when you come to class tomorrow. But that is my answer. So now let's look at the next example. The next example has 2 sets of things going on. I have 2b times this quantity minus 3b times this quantity. So I'm going to have to distribute twice. I'm going to have to distribute this part first and then over here, and then I'm going to have to subtract the 2 resulting polynomials. So this sort of combines what we're learning today with what we learned yesterday. So let's take care of the distribution first. 2b times b squared becomes 2b to the third, because remember there's that invisible 1 there, you add your exponents. Then 2b times 4b becomes 8b squared, because b times b is b squared. And then 2b times 8 becomes 16b. Now I'm going to put that in parentheses because I'm going to have to subtract something from it, and it's a quantity, so I'm going to keep it together. So I'm going to put another set of parentheses here, and I'm going to multiply. 3b times 3b squared becomes 9b to the third, for the same reason that that was b to the third. Then 3b times 9b becomes 27b squared. And then 3b times that negative 18, that becomes 54b. And now I have to subtract these 2 pieces from one another. So remember, like terms with like terms, and keep up with the fact that this is a subtraction symbol here, so we got to take care of it. So I have 2b to the third minus 9b to the third. And 2 minus 9 makes negative 7b cubed. Then I have 8b squared minus 27b squared, which makes negative 19b squared. And then I have 16b minus negative 54b, so I have that minus a negative, so I have 16 minus negative 54, which is going to be 70b. And this is your final resulting polynomial from that problem. So I had to distribute twice, then I had to subtract. So be careful, you pay attention to what kind of operations you have going on. And so now this last one, it looks very complicated because there are fractions, but this 5 right here actually makes this work out very nicely, because if you notice, all of your denominators happen to be multiples of 5. So we're going to multiply first. So I have to do negative 5x squared times 1/25 x squared. Well, when I do negative 5 times 1/25, I end up with negative 5 over 25, because I just do negative 5 times that numerator, and this becomes x to the 4th, because when I add exponents, that becomes 4. Now this negative and this negative make a plus sign, so when I multiply here, I still get 5 over 25 again, but now I have x to the 3rd power, because I have a squared with a 1, so that makes 3. Now this negative and this positive way over here makes another negative, and this becomes 5/5 x squared. And so now I can simplify. If I want to simplify 5 over 25, well, they both divide by 5, so this becomes negative 1/5 x to the 4th plus 1/5 x cubed minus 1 x squared. So here is your final polynomial. This is a degree 4 polynomial because that highest exponent happens to be a 4, and it's a trinomial, so those are things to remember. And so that's what that looks like. And so yes, it had fractions, but they weren't that difficult of fractions to deal with. Just keep up with them. It's not a big deal. So that's how we do that. So let's look at a couple of word problems just to make sure we can apply it in a situation where it's not just handed to us. So Ria's cornfield is shaped like a rectangle. Means I probably need to draw a rectangle. The length of one side is 3 meters less than twice the width. So if this is the width, then the length is 3 meters less than twice the width. That means twice the width minus 3. So here is the other side. We want an expression in simplified form to find the area. Well, area of a rectangle is length times width. So I'm going to multiply the length times the width. So I have W times 2w minus 3, and I'm going to multiply those. Well, this becomes 2w squared, and when I multiply this way, this becomes minus 3w meters squared. That is your area. This m squared, y'all, is just my units. My units were in meters. When I find area, I have to label with my units. It's meters squared. That's all that represents. I didn't make up a new variable and just stick it in the problem. Those are just the units. Please don't freak out. This is the polynomial that you need, 2w squared minus 3w. That's the expression in simplified form. This m squared is just my units. Okay, so let's do another one. So now we're going to find the area of the shaded region. So let's think about what that means. Way back in 8th grade, when you did area of shaded regions, what you did was you found the area of the whole thing and subtracted the area of the part. And that gave you the shaded part. So that's what we're going to do. We're going to find the area of the whole big rectangle, and then we're going to find the area of the little bitty rectangle, and then we're going to subtract them. So let's do the whole first. The whole rectangle is 3x and 4x minus 6, so I have to multiply length times width. So this becomes 12x squared, and this becomes 18x. So there's your whole. Now let's do the part, which is the little square inside, which is going to be x times x, which we all know is x squared. And to figure out the shaded part, I just have to subtract them. So I have to do 12x squared minus 18x minus the x squared for the little part. So like terms with like terms, I have 12x squared minus x squared. Well, 12 minus 1 is 11x squared. This negative 18x has nothing to subtract from it, so it just becomes minus 18x. This is your shaded region, and if I want to put my units, it is feet squared. Do not fear the units. It's okay to write them. Again, I didn't make up new variables. It's just my units, okay? So your polynomial for the shaded region is 11x squared minus 18x. So there are word problems to apply that. We will practice this when you come to class tomorrow. I will actually be there tomorrow so we can move on and get on with things, and I will see you then.